All right, today's lesson is GoMath, lesson 12.4, representative algebraic relationships in tables and graphs. And so we utilized a big part of this already in our enrichment lesson on Friday. And just a quick review, just on some of the challenges that we had. You were asked to take this equation. It's basically a little code. You have a starting point, and then you are given that slope on going over and up. Some of you guys, absolutely perfect work. I can see you're thinking with your details to the side. The one problem area that we did have was in areas of this, when we had that starting point of +3. I would say almost half of you guys at different times started that on the x-axis. All right, so even though your slope was right, over 1 and up 2, all right, so you can see that over 1 up 4, the starting point is completely different. And then, in conferencing with some of you guys online, I came up with this idea right here. So whenever it comes to your starting point, if you guys can create this model or just use it visually, use post-it notes on your graph paper or on your screen and cover up that x-axis. You can't even put a point on it. And now you're forced to match that starting point. What is it? I see some of you guys putting that parentheses. That's a great strategy because now I see that that needs to start on -1, and now I need to put it there. It'd probably be even more helpful if I moved those over even more, so I can't be forced to put it on the x-axis. The y-axis is the starting point, up and down. Okay, and then I go from there. What is my slope? Over 1, 2, 3, up 1. All right, and then some of you guys getting a little lazy, even though every single one of my examples had 3 points. Some of you guys just doing this as your line, and it's not acceptable. You'll never get credit for that on any level. So this is why you need to use that strategy that you were given and to do it and to take the effort and to make that line. And technically the line goes on forever, so you need to show a line which is with the arrows on both sides, please. All right, so today what we're going to do is GoMath's approach to it, and they take it back a level by they want you to use a table first. All right, so in this case, to go back to the original problem, I'm just going to jump for a second. All right, so they want to show that Angie's walking speed is 5 kilometers an hour and May's is 4 kilometers an hour. All right, so we need to then plot that in a point, and you can see now that we're going up by 5s, right? So I can complete that table. All right, and so I would go down below here. So for Angie, and it's going to be a little hard for me to do this on a smaller screen, but I'm going to plot my points. All right, and then I'm going to go up and over 5. All right, so in this case, it's going up by 2s, you'll see, right? So in between at 6. And so the first point is going to be the 5, so that's in between. All right, so that's going to be down there. So for 2, that's up 10. There it is. For 3, that's 15. So in between would be 14. Halfway between 14 and 16 is 15. And then it would be there. So not the best use here on the smaller screen. All right, so your lines will be better than mine. And then for May's, I'm going up by 4s. All right, so 1 hour over, I go up 4. This one's going to be easier, right, because it's exactly based off of my coordinates on the side, right? So 2 is 8. And then 3 I need to complete. I'm counting up by 4s. So 12. And then 4 is 16. All right, so I use connecting. All right, so the equation, again, is what am I going up by? So I would rewrite that Km equals 4h. This one, 5h, excuse me, 5h. This one would be kilometers equals 4h. Right, notice how there's 2 variables on each part of that. Please make sure you're doing that. Oh, and then going back there, they want you to use the variables that are given to you. All right, so shows that even I need to follow directions at times, right? So it needs to have the y and the x. So I'm going to set that up for both of them, right? Because again, a lot of you guys aren't doing this part. All right, so the first one, what am I going up by? 5. So notice I have the 2 variables. That one's set, and this one's going up by 4. It has the 2 variables, so this one is set. All right, how can you use the tables to determine which girl is walking faster? Well, there's a couple ways you can do it. You can look at starting points, right? And you can see after 1 hour, the first person, Angie's time is is farther, so that means she is walking faster. All right. In terms of using the graphs, what you would do then is you would see that this line is steeper. All right. So a steeper line means it's going up by a greater increase. So that's how you're going to be using that going forward here. All right. So writing an equation from a graph again. All right. So now you're given a table and you're given a graph, and then they want you to go backwards at time. So what is the pattern in the table? What do we have? Charisse pays the entrance fee to a museum, then buys souvenirs at the gift shop. The graph shows the relationship between the total amount she spends at the museum and the amount she spends at the gift shop. Write an equation to represent the relationship. All right, so what do we have here? We're going up by, in this case, we're going up by 5s, right? All right, so what would that be? I keep going up here on the bottom, and at the top, I'm going 20. All right, so what is the pattern in the table? All right, so what is my gift shop amount? My gift shop is going to be X, and my total amount is going to be Y. All right, so how do I do that now? There's a couple ways I can come up with that, right? So it's always good to check my work. I'm going to start my equation, and now how do I go from X to Y? I'm either timesing or I'm adding, right? And which one is it? Can't times and go from 0 to 5, all right, but I can add. So if my rule is plus 5, now that should match up, right? Take a look at the next amount. Is putting 5 in for X, is that equal 10? My pen is not working, so let's take a look here. 5 plus 5 is 10. That is my rule, okay? So that's my pattern. That goes here. Write an equation that represents the total amount spent in Y in terms of the, I already did that. So the pattern would be adding 5. The equation I already did. All right, identify the dependent and independent quantities. All right, so again, how do I know the difference? All right, X across, Y is here, right? Gift shop amount will determine the total amount. All right, the X determines Y. Right, draw a line through the points on the graph. Find the point that represents Therese spending $18 at the gift shop. All right, so $18 at the gift shop would be in between 16 and 20, right? So again, really hard to do when it's not blown up, but that would be here. All right, and that would be 23. Use the equation to represent to see if it works, right? So here we go. I'm putting 18 in, plus 5 my rule, and that does equal 23, and that matches to verify my answer. All right, so graphing an equation. So we've done this before, right? You did that by just looking at it. What is my starting point, and then finding my rule, right? So if X is there's that point intercept form, right? Slope intercept form. That's my starting point. And now here's my slope, and I don't have a number in front, right? But that meant that I would do this. So over and then up. So take a look here. What they wanted you to do is use a table now and to put your x's in. All right, so when x equals 1, y would be 2, right? 1 plus 1 is 2. If x equals 2, you're going to add 1 to it. It equals 3. And so that is my graph. And notice how it's exactly the way we did it on Friday. What's my starting point? Positive 1. All right, and then I'm going over 1, up 1 from there. So it matches. All right, so you can use a table or you can use the strategy we worked on Friday to do that. All right, take a look here. What do we have? Y equals 2x. All right, what's my starting point? Again, there's nothing there. So I saw some of you guys writing this in on that one on your homework, which was great. Plus 0 would be the same as starting it in, and that means starting it in the origin. In this case, we only have one quadrant, right? So you would just start it at 0, 0. And so what does this mean now? So every time I have an x, I am going to now times it by 2, all right? So my y variable would be 2. When x equals 2, I plug it in at the top. 2 times 2 is 4, etc. All right, and the other way to look at that is using my slope, right? So my slope, again, is over and then up. What number is on my bottom? It would be 1 since there's not a number there, so I go over 1 and then up 2, and you'll see that now is true. So just be careful because you'll see my units on the left are going up by 2, and my units on the right are going up by 1 when it comes to the boxes, right? So in between is 1/2. Over here, in between is 1. All right, but it still matches, so I'm going over 1 unit, and then I'm going up 2 units there, and that is where I get my slope of my line. All right, so let's use our table now to do this. All right, so your turn. So x. All right, so if x equals 0, 1, 2, and 3, so you would now complete the y. So I'll give you guys a moment to do that. And then I have the example from the homework to show you guys how you would start it, right? I'm putting x into my equation now. 0 plus 2.5, 2.5. Putting 1 in for x, so that becomes 3.5. Putting 2 in for x, that's 4.5. 3 in for x, that would be 5.5, sorry. All right, so now I have my my points right here, right? I would just put the two together. So for purposes of time, I'm just going to put commas here, right? And now I would go over here and would find my starting point, all right? So use our slope-intercept form, right? So what do I have? 2.5 is my starting point, right? So where would that be? That would be 3, so it's in between 2 and 3. It would be right there. And now what I'm going to do, what is my slope? It is x, so also known as 1 over 1. And I could use that, or I could use my points now. All right, so I already did 0. When I do 1, I go over 1, up 3.5. Where is that? That is here. I go over 2, 4.5, right there. I go over to 3.3, and I go up 5.5. So where would that be? That would be there. Now I connect my dots. All right, so there we go. So again, this is a good, helpful tool. And notice that I didn't start right here on 2.5. I started on the y-axis. All right, here's a word problem now in guided practice. Make a table to show the relationship between the number of hours Frank works, x, and the number of lawns he mows. Graph the relationship. All right, am I missing something there on my page? Or am I coming up with that rule? I don't have that in front of me. All right, so you might have that there. Hours worked, lawns mown. I don't know if that's on the page or not. All right, so I'm just going to skip over that for now. Let's use this graph here. Make a table to show the relationship. We have x being 0, 1, 2, 3, and I'm going to make my y's now. So if I put 0 in for x, that would be 0. If I put 1 in for x, 1.5 is 1.5. If I put 2 in for x, that's going to be 2 1.5s. So hopefully you guys can do that in your head. If not, show your work. So that would be 3, 1 decimal point, that's 3, and then adding 3 1.5 is 4.5. All right, so now I'm going to graph, starting on the origin 0, going over 1, up 1.5. Notice that my units are going up by 1s on the side, but in between is my halves, right? So I go over 1, up 1.5. It would be there. I'm going to zoom in on these from now on when I'm graphing points so there's no confusion, right? Over 2, up 3, and over 3, up 4.5. In between 4 and 5 is there. Now I connect my dots, and there's my slope. All right, so you guys are going to practice now using independent practice. All right, so just make sure that you guys are using the information right. So in this case here, plot your points based off of, or do your amounts in your tables based off of the graph, then write the equation. All right, so that one's going to be a little bit easier to do and to find that rate and pattern once you have the numbers in the table. To find the relationship here, you're given that slope. All right, so again, there's two ways to do it, right, based off of the table and then the way we did it on Friday. But it's good to know how to do it both ways. Here we have a different equation. We have 9x being the rule. All right, and then just some thinking questions here. All right, so please do not put for the answer, I don't get this one, or I don't know. Please try to think it through. I'm giving you guys a lot of credit just for thinking and trying. I don't know or I don't understand is not acceptable. Okay, so please try that and try to explain yourself. All right, any questions, let me know. And again, it's basically just taking what we talked about on Friday, but taking it a step backwards using the table and then showing it to prove that your slope matches based off of the rate of change.